We are currently falling through the void at an incomprehensible speed. The Earth orbits the Sun orbits the galactic center, but the entire Milky Way galaxy itself is plunging through intergalactic space at over 1.3 million miles per hour. This is not a gentle drift along a quiet cosmic current. It is a violent, relentless migration across the cosmos, driven by a force so massive it dictates the absolute movement of our entire cosmic neighborhood. Every single star you can see in the night sky, every glowing nebula, and every neighboring galaxy within millions of light years is caught in this exact same invisible undertow. Andromeda, the Triangulum Galaxy, and dozens of smaller dwarf galaxies are all locked into a unified, inescapable trajectory. We are a collective swarm of hundreds of billions of stars hurtling blindly toward a specific, highly concentrated coordinate in the endless, freezing black of the universe. That focal point lies roughly 150 million light-years away, anchored by a terrifying anomaly known as the Great Attractor. This region of deep space possesses a gravitational pull so overwhelmingly powerful that it overcomes the background expansion of the universe itself. It holds the mass equivalent of tens of thousands of Milky Way-sized galaxies, a staggering concentration of dark matter and luminous gas that violently warps the very fabric of space-time around it. The sheer mechanics of this cosmic pull completely defy human intuition. Space is not an empty, static theater where galaxies sit in peaceful isolation. It is a dynamic, tightly interconnected web of dark matter filaments, and the Great Attractor acts as a colossal gravitational basin. It drags immense cosmic structures down into its gravity well, forcing entire clusters of galaxies into high-speed, catastrophic collisions that rip star systems apart and flood the void with superheated radiation. Yet despite its terrifying magnitude and profound influence on our trajectory, we cannot simply look up and see the monster pulling us into the dark. The Great Attractor sits perfectly concealed behind what astronomers call the Zone of Avoidance. This is the dense, luminous equatorial plane of our own Milky Way galaxy, a blinding wall of interstellar dust, swirling gas, and billions of stars that completely blocks our visual observation of the universe beyond it. For decades, this massive blind spot tormented observational astronomers. The cosmic microwave background radiation, the ancient afterglow of the Big Bang, revealed a distinct and unsettling temperature shift across the sky. One half of the universe appeared slightly warmer and blue-shifted, while the opposite side was cooler and red-shifted. This cosmic Doppler effect provided the absolute proof of our immense velocity, the smoking gun that our galaxy was being violently yanked in one specific direction. To pierce the blinding veil of the Zone of Avoidance, observers had to abandon visible light entirely. By tuning sensitive instruments to detect high-energy X-rays and radio waves, which easily penetrate thick interstellar dust, a hidden landscape began to emerge from the darkness. Deep within the obscured region, they discovered the Norma Cluster, a massive, chaotic collision of galaxies, generating intense, screaming radiation as they slammed together at millions of miles per hour. The Norma Cluster is a site of absolute cosmic violence, but the mathematical reality of its mass quickly presented a new, deeply terrifying problem. It is undeniably massive, but it is nowhere near massive enough. The gravitational force required to drag the Milky Way and our surrounding galactic neighbors across the void is vastly greater than what the Norma Cluster alone can generate. The true source of the pull remained partially hidden, a phantom weight stretching across the dark. To comprehend the true nature of this invisible force, our perspective must expand far beyond isolated galaxy clusters. Galaxies gather into localized groups. Those groups merge into massive clusters, and those clusters weave together into sprawling, interconnected superclusters. We belong to the Laniakea supercluster, a colossal structure containing roughly 100,000 galaxies strung along glowing filaments of dark matter, spanning over 500 million light-years of empty, freezing space. Laniakea translates from Hawaiian to immense heaven, a fitting and poetic title for the massive gravitational watershed of our local universe. When astronomers finally mapped the complex flow of galaxies within this immense heaven, they realized the Great Attractor is not a single dense object. It is the gravitational focal point, the central inescapable valley of the entire Laniakea supercluster, where the collective mass of thousands of galaxies creates an overwhelming cosmic drain. From this elevated vantage point, we are nothing more than a single drop of water in an intergalactic waterfall. The forces driving this vast migration are entirely impersonal, utterly indifferent to the fragile, rocky planets and the microscopic life they might carry. The Great Attractor does not hunt. It simply exists, a towering monument to the crushing, inescapable authority of gravity on a scale that renders human existence mathematically insignificant. Within the turbulent core of this gravitational basin, the universe is actively forging its largest and most violent structures. As galaxies pour into the Great Attractor from every conceivable direction, they are brutally stripped of their star-forming gas. The immense friction of this intergalactic convergence superheats the surrounding environment to tens of millions of degrees, creating vast, invisible clouds of plasma that emit relentless torrents of X-ray radiation into the silent void. Yet, as we precisely map the violent mechanics of Laniakea, a deeper, more profound mystery bleeds into the data. The Great Attractor explains the immediate high-speed velocity of the Milky Way, but it completely fails to account for the movement of the entire supercluster itself. Even as we fall toward the central basin of Laniakea, the entire structure, including the Great Attractor, is being dragged towards something even more massive, lurking further out in the unlit depths. Far beyond the borders of the Laniakea supercluster lies the Shapley supercluster, an even denser, more terrifying concentration of mass located roughly 650 million light-years away. It contains immense, tightly bound clusters of galaxies that absolutely dwarf our own local neighborhood. The Great Attractor is merely a localized stepping stone, a temporary eddy in a much grander, more violent cosmic river flowing relentlessly toward the overwhelming gravity of the Shapley concentration. This nested, repeating hierarchy of gravitational dominance reveals a universe far more structured and heavily interconnected than we once dared to imagine. Galaxies do not scatter randomly across the void. They strictly trace the invisible underlying architecture of dark matter. The Great Attractor and the Shapley supercluster are simply the visible glowing nodes of this unseen web, pulling matter across hundreds of millions of light-years, dictating the ultimate fate of trillions of ancient stars. To look up at the night sky is to look at a beautiful, comforting illusion of stillness. The tranquil, glittering canopy of stars completely hides a reality of terrifying kinetic energy and unstoppable momentum. We are trapped in a complex, multi-layered free fall pulled by the Great Attractor, which is in turn pulled by the Shapley supercluster, all while the underlying fabric of the universe itself stretches and tears at the seams. This universal stretching is driven by dark energy, the mysterious, repulsive force actively accelerating the expansion of the cosmos. In the deep, empty voids between superclusters, dark energy reigns supreme, pushing matter apart at ever-increasing speeds. But in our local corner of the universe, the sheer gravitational density of the Great Attractor is actively fighting a brutal war against the expansion of space itself, holding our supercluster together through sheer violent mass. The discovery of this localized, hard-fought victory over dark energy completely redefined our understanding of cosmic evolution. Early cosmological models assumed a relatively uniform expansion, a universe spreading out evenly and predictably in all directions. The shocking realization that immense, invisible gravitational anomalies could halt this expansion and drag thousands of galaxies backward against the cosmic tide forced a radical, immediate rewriting of astrophysics and structural mechanics. And still, the impenetrable zone of avoidance fiercely keeps its deepest secrets. Even with our most advanced X-ray observatories and sensitive radio telescopes, we are only seeing the brightest, most violent interactions flashing in the heart of the Great Attractor. The vast majority of its immense mass is dark matter, an invisible, untouchable substance that does not emit, absorb, or reflect any light. We can only map its ghostly presence by the gravitational terror it inflicts on everything around it. Dark matter forms the dense, skeletal structure of the Laniakea supercluster. The brilliant galaxies we see, including our own spiral Milky Way, are merely the luminous dust settling on these massive, invisible bones. The Great Attractor is the ultimate nexus where these thick, dark matter filaments intersect, creating a gravitational well so impossibly deep that it binds 100,000 galaxies into a single, cohesive, rapidly moving cosmic entity. As we travel endlessly along these dark matter highways, our own galaxy is slowly being warped and tested. The immense tidal forces exerted by the Great Attractor and the surrounding supercluster subtly influence the outer edges of the Milky Way. Over billions of years, this continuous, agonizing gravitational stress will distort our galactic disk, pulling our halo of ancient stars into elongated, trailing streams that point like compass needles toward our ultimate destination. There is a profound, deeply unsettling finality to this grand cosmic migration. We are falling headlong into a region of space where galaxies go to die. As massive clusters merge within the Great Attractor, the incredibly violent collisions strip away the cold, vital gas necessary to birth new stars. It is a cosmic graveyard in the making, a dense, superheated environment where star formation is choked out by the sheer brutality of gravitational convergence. The immense timeline of this journey, however, offers a strange, cold reprieve. The Milky Way is moving at 1.3 million miles per hour, but the Great Attractor remains roughly 150 million light-years away. At our current staggering velocity, it would still take tens of billions of years to reach the dead center of the anomaly. We are actively participating in a catastrophic collision that we will never actually survive to witness. Long before we ever reach the dark heart of the Great Attractor, the Milky Way will face a much closer, equally violent fate. We are currently on a direct, unavoidable collision course with the Andromeda Galaxy, our nearest massive neighbor. In roughly 4 billion years, our two galaxies will smash together, igniting a firestorm of star formation and gravitational chaos, all while the newly merged remnant continues its relentless, silent plunge into the dark. The cosmos is not a peaceful painting. It is a theater of perpetual motion and overwhelming destructive force. The Great Attractor stands as a stark, terrifying reminder of the invisible powers dictating our existence. Hidden forever behind the blinding light of our own galaxy, it silently pulls the strings of the Laniakea supercluster, dragging us endlessly across the void in a grand, terrifying migration toward an unimaginable concentration of mass.